Hi children, today you are going to learn 8th class 4th chapter, that is exponents and powers, in that last exercise number 4.2. In this exercise you are going to learn about standard form and usual form. So what is standard form and what is usual form? Let us learn here first. The standard form, what is meaning of standard form? If a number is set If a number is said to be a standard form, it is in the form of a product of a number and power of 10. Then the since the standard form is equal to m into 10 to the power of n. In this form, the standard form always will be m into 10 to the power of n. What is m here? In the sense, the m is always is greater than or equal to 1 and less than 10. The m value should be greater than or equal to 1 and less than the 10. This must be, we have to remember. Suppose for example, here you want to write 5, 6, 7, 0, 0, 0, 0, 0, 0. Suppose this is called a usual form. This is called as a usual form. Normally we used to read the numbers in this way. So, if a number is very big, it is very difficult to read. To make it convenient to us, when the numbers are very difficult to read, when we write those numbers in the standard form, so it is very easy to read. That's why we use the very large numbers to read very easily. We use the standard forms. But there will be some rules to write the standard forms. I will tell you that. See, this number is unable to read now. So how to write these numbers in the standard form? This is the usual form where we used to write regularly. We used to write the numbers in this form. That is called usual form. So let us write these numbers in the standard form. So if you want to write in the standard form, see that one number, the numbers at least, the number should be one number after at least a decimal before. The integer part should be greater than or equal to 1 or less than 10. See, the decimal place should come here till here. See, 5 point. The decimal, there is no decimal point here. The decimal point should come till here. Just count that how many decimal points are there. So, here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So, 11 points we are moving from right to left. From right to left, we are moving 11 points. So, write the remaining number 5.67 into 10 to the power of 11. So, how many decimal points, how many digits you are moving from right to left, then you write as many in the power of 10. As well, the number you have to write in the power of 10. So, if you are moving the decimal point from the right to left, will get a positive exponent. If the decimal, see now, the decimal point is here. If a decimal is moving, see, this is a usual form. Now you have to write in the standard form this decimal has to move at least one digit. See that this digit is greater than or equal to 1 and less than 10. So this is called integer part. The integer part should be greater than or equal to 1 and less than 10. That you have to remember. So at least one number should be before the decimal point. That is what I want to tell you. So here it is 0. If you put a decimal point here, it will be 0. It is not greater than 1. So the decimal point should be moved till here. So how many places we have to move here? 1 digit, 2, 3 and 4. 4 digits we have to move it forward. From what? Here left to right. When you are moving a decimal digit from left to right, we get a negative integer. That means we get a negative exponents. But when we are moving from right to left, we get positive exponents. See, so here we give it. The decimal point will come here now. As 7.83 into a number into the product of tens, the power of the tens. What should be a power should come here? See how many digits we are moving from left to right. 4 digits. So 10 to the power of minus 4 we have to write, because we are moving from left to right. When we are moving left to right, we have to write minus as a exponents. When we are moving right to left, we have to write positive number as exponent. Now these numbers are in the standard form. Before that I have given in the usual form. So let me give you some more problems. See, now here, suppose here 276300000000000. So see that this number is very difficult to read, but we can make it positive. We can make it into very easy form. This is a usual form. When you write this in the standard form, we can read it very easy. The rules of standard form is that there should be a number before the decimal that should be greater than or equal to 1 and less than 10, and the remaining all the numbers should be in the decimal place, and it should be a product of power of 10. There should be power of 10s also. See that we have to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. See that only till 14 I have counted, not 15, because the decimal point should becomes here. So 2 point, this number you write as it is 763 into 10 to the power of plus 14. Plus 14, because the decimal point, here there is a decimal point. See, 0.000 in the sense there will be decimal point will be here now. This decimal point is moving from right to left, so we get positive exponent. We get a positive exponent. In the same way, let me give you one more example. Usual form. Usual form. Suppose 0.0000000734669. Suppose this is a number. This is also a usual number. Can you read this now? It is difficult. So, in a very easy way we can read. The condition is at least one number should be in the decimal part, that means in the integer part, and the remaining numbers should be in the. Here what exponents should become, what powers will come, that's what. This decimal point should be moved till here. So let's count. 1, 2, 3, 4, 5, 6, 7, 8. 8 digits is moving. How? From the left to right. If it is moving from left to right, it should get negative exponent. So -8. Now this is what? Standard form. So these two are the standard forms. So before that is usual form. So in this exercise we are going to learn the changing numbers from standard form to usual form and usual form to standard form. Both, only that we are going to be learning. So this is the standard form definition, that we must know that if a number is said to be a standard form, should be in the form of a product of a number and the power of 10, and the standard form equal to m into 10 to the power of n. N in the sense any exponent here. M in the sense that is a number which is greater than or equal to 1 and less than 10. Okay, so let us directly enter into the exercise and we'll solve the problems from the exercise. There are some problems in the 4.2. First bit, first question. 0.00 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9, 4, 7. So this we need to write in the form of standard form. So we have to write in the standard form. Standard form in the sense, already I said to you that there should be one number in the decimal part. Okay. So this decimal point should move till here. Just count that how many digits are there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 10 places it has to move. It should be moved 10 places. So 9.47 into any 10 places. So 10 to the power of minus 10. Minus 10. Why did I write minus 10 in the sense? Here it is clear that the decimal point is moving from left to right. When it is moving from left to right, it should get minus as an exponent. From right to left, we have to get plus exponent. That will be. So this is completed. So in this way we can do it. Or there will be other process also to do this. So this decimal number you change in the form of a fraction, and thereafter we have to change in the powers of 10. It will be difficult. So remember this, how we are doing it. Very simple method. So here the second question, 543. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes. Yes. This should be. See that? Now the decimal point is not here actually. So the decimal point should be at last only. So there is no decimal point in the given number. So it is the usual form. So think that the decimal point is the last. It has to move till here. Count that. 5.43 should come into 10 to the power of something should come here. So see that the decimal point is moving from right to left. Count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So into 10 to the power of 11. Only 11 decimal places it is moving. So see that this is called as a m. This is m. It is greater than or equal to 1. It is less than 10 also. This condition is satisfied. So standard form definition you must know that. What is standard form? So the third question is that 483. 1, 2, 3, 4, 5. Okay. Let us see again the same. It is a usual form. Let us write in the standard form. So 4.83 into only one number should be in the before the decimal. If you write 48.3, what happens? Here this number will consider as a m, but m should be greater than or equal to 1 and less than 10. So but we have 48 is more than 10. So we should not use that. So here we write 4.83 into 10 to the power of, here we should write what actually? See the decimal point at last. Count 1, 2, 3, 4, 5, 6, 7. So 10 to the power of 7. 10 to the power of 7. The decimal point is moving from right to left. So we take plus. So again, we will take it here. The question number 4, 0.00009298. So here the decimal point is n. This decimal point should move till here. Okay, let us count. Here 9.298 into 10 to the power. Let's write what should write here. We know that the decimal point is moving from left to right, so we get negative exponent. How many digits is moving? 1, 2, 3, 4, 5. 5 digits is moving. So after 5 digits only. So 10 to the power of minus 5. Simple. Here the thing you have to be remember this. So when the decimal is moving from left to right, we get a negative exponent, and when the decimal point is moving from right to left, we get a positive exponent. Negative and positive exponent. Okay. Then the fifth one and the last one of this bit 0.00000529. Okay, let us, this decimal point has to move till here. So check 1, 2, 3, 4, 5. Okay. 5.29 into 10 to the power of minus 5. Because 5 digits is moving right side. Simple. Now in this way we can write the usual numbers into the standard form. Usual numbers into standard form. Usual form to standard form. So I hope you understood that how to change the numbers from usual form to standard form. Now we are going to be change the numbers from the standard form to usual form. Standard form to usual form. That is in the second bit. In the second bit all the problems are express the following numbers in usual form. So there are 6 problems here. Let us try to do it. 4.37 into 10 to the power of 5. So 10 to the power of 5. Let us write that 4.37 into 10 to the power of 5. So this 4.37 will write in the fractional form. So what we get? 437 by 100. Because here there are two decimal places. Okay, we get here by 100 into 10 to the power of 5. So here 100 we can write 437 by 10 square into 10 to the power of 5. Here two tens are there, I cancelled. Out of 5 we cancelled 2, we get 3. So 437 into 10 to the power of 3. 10 to the power of 3 in the sense 433. 437 into 10, you multiply 3 times, you get 1000. So multiply this all, 437, 0. This is what we will get answer. Or else, if you are feeling this is as a difficult, then I use the another method to make you simple. Okay, this method, if you are feeling difficulty, I will tell you how to write again. So see that this decimal has to be removed. So in the standard form, so there should be no decimal point should be here. So I am going to be remove this. So the decimal is moving from left to right. Here it should come. So 437 into left to right should be negative 10 to the power of minus 2. 2.6 moving here into 10 to the power of 5. Here we use the formula that a to the power of m into a to the power of n, that equal to a to the power of m plus n. So that is 437 into 10 to the power of minus 2 plus 5. 5 minus 2 is 3. 437 into 10 to the power of 3. 10 to the power of 3 in the sense of 437 into 10 to the power of 3 will give us 1000. That is equal to this. So here 4,37,000. It is a usual form. Usual form number. Then next, there is a question here. The second one, 5.8 into 10 to the power of 7. Very simple. See, this decimal should move till here. 5.8 should not come. So completely we have to get 58. So we go for that. 58 into only one decimal digit is moving. So 10 to the power of minus 1 into 10 to the power of 7. Again same formula we will use it here. 5 into 10 to the power of minus 1 plus 7. That is equal to 58 into 10 to the power of 6. 7 minus 1 is 6. That means 58 into 1, 2, 3, 4, 5, 6. You write completely, you multiply 1, 2, 3, 4, 5, 6. So this is the usual form. Simple. Now we go for the third one. 32.5 into 10 to the power of minus 4. So here this decimal should move one digit again. So completely there should be no decimals should be here. A decimals so 325 into only one digit is moving from left to right. So 10 to the power of minus 1 into 10 to the power of minus 4 already is here. So we use the formula again. So we get 325 into 10 to the power of minus 1 minus 4. That equal to 325 into 10 to the power of minus 5. 10 to the power of minus 5 in the sense, here we can use the formula that a to the power of minus n equal to 1 by a to the power of n. Or else, if you don't want to use this, simple that if there is a negative exponent, you must meaning that you should be remember that. So there are minus 5. That means 5 digits you have to move from right to left. Okay, from right to left if you are moving. So it should becomes like this. So see that here 5, 2, 3. Okay, so here when it is, so here to come only 3 digits are completed. 1, 2, 3 digits are completed. 2 more digits we have to do. 1, 2, 1, 2, 3, 4, 5. Point 0. 0.00325. This will be the answer. See here minus 5, no? It has to come in the decimal points. So we have to write in the decimal. So we get that 5 points we have to count. 1, 2, 3. And remaining 2 digits are not there. So keep as a zeros. So completely there are 5 digits after there is a point. So else if you are feeling difficulty for this, in another method we can do that. See that 325 into, in the formula form you change it 1 by 10 to the power of 5 you get. That means here you will get 325 by, this is 1, 2, 3, 4, 5. So this fractional you change into the decimal now. Simple. There are 5 zeros here. So after 5 digits you have to keep a decimal point. 5, 2, 3, 0, 0, 0.0. So in this way also you can do it. So this negative exponent you change as a positive. When you write in the denominator it will be positive. From there you change in the form of tens. Then count the number of zeros here. As many zeros are here, count as many numbers, decimal places in the numerator part and write the zeros. That you can do it. Or not, when you get a negative exponent, see, when the digit is moving from left to right, you will get a negative exponent. So you have to count in the same. From left to right, how many digits should be there? 5 digits should be there. Then only it will be satisfied here. So here minus 5 is there should be 5 digits to the left side. 1, 2, 3, 4, 5. It is satisfied. So in that way we can do this. And one more problem I will tell you in the same method so that you can do it. The remaining problems of this bit you do it now. Now next I will go for fifth one. 3, 7, 8, 9 into 10 to the power of minus 5. So see that there should be 5 digit answer, there should be decimal. Okay, so here 1, 2, 3, 4, here 9, 8, 7, 3, 5 digits after there should be decimal. So 0, 1, 2, 3, 4 after 0. Simple. Is it clear now? Very simple that how I made it. Very simple. Here also I can make it very clear again. Okay. So here also we can do it very small way. Let's go for one more problem to be avoid doubts. 24.36 into 10 to the power of minus 3. See that how we are going to do it in the easy method here. Either you can do in this method or not in this method what I am telling you. So see that this minus 3 is there. That means this decimal should move 3 digit left side again. So let us move it. Here 1, 2, there should be one more digit should be here. 6, 3, 4, 2. Only 2 digits is came here. One more digit should come. So to satisfy this. So that will keep a 0.0. So see that here there are 2 digits and here minus 3 digits. So completely 5 digits should be there. 1, 2, 3, 4, 5. In this way you can do it. Or else, see already there are 2 digits here. So minus 3 digits, you have this digit has to move 1, 2 and 3. 3 digits is 0. Point here should come there. Or else, see that this you write now 2, 4, 3, 6 into 10 to the power of minus 2. See that this decimal is moving from left to right. So get minus into 10 to the power of minus 3. So completely 2, 4, 3, 6 into 10 to the power of minus 2 minus 3, that equal to 2, 4, 3, 6 into 10 to the power of minus 5. So this digit, there should be 5 digits after, there should be decimal here. 6, 3, 4, 2, 0, 0.0. 1, 2, 3, 4, 5. So in this way you can do it. There is no problem. So only one problem I left in this bit. There is a fourth one that you need to solve it. So now we go for third bit. Third bit questions are that express the following information in the standard form. As I told you how I done with standard form. In the same way here also we have to do it in the standard form only. Third bit completely. See that they have given the size of the bacteria. The size of the bacteria is very small actually. So that we need to change it. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6 is 4. So meters. This we need to change in the standard form. Standard form in the sense there m should be. That means before the decimal there should be a number which is greater than or equal to 1 and less than 10. So this decimal should be moved till here. Till here in the sense left to right. Left to right will get minus. So 4 point. Okay, or not 4 point. There is no number no. So into, see that how many digits? 1, 2, 3, 4, 5, 6, 7. So 10 to the power of minus 7 meters. Okay. So here this is 1, 2, 3, 4, 5, 6, 7. So 7 digits we have to move. So 10 to the power of minus 7 I have written. So the second one, the size of a red blood cell is 0.000007 milli micrometers. Okay, micrometers. Then how to change this? Again, this decimal should be moved till here. So see that 1, 2, 3, 4, 5, 6. There are 6 digits we have to move. 7 into 10 to the power of minus 6. Simple. And you should not write that 0.7 because this 0 is greater than, not greater than the 1. So we will take only here the number which is less than 10 and greater than or equal to 1. That is m value. That I told you in the standard form how to write the standard form. The speed of the light in the sense, so 1 2 3 4 5 6 7 8 1 2 3 4 5 6 7 8 meter per second. So let us write here. See, there is no decimal. There is a decimal here. Here there is a decimal. So this decimal we are moving it till last. So there is no decimal. Here decimal should come till here. So count that there is a 8 digits are there. 3 into 10 to the power of 8. 3 into 10 to the power of 8 meter per second. And the fourth one, the distance between the moon and earth. The distance between the moon and earth. Okay. The distance between the moon and earth is given. So this is in the usual form actually. Can you read this? It is a difficult. So let us convert it to the exponential form. So the decimal is not here completely. So decimal you think that is in the last. It has to move till here. 1, 2, 3, 4, 5, 6, 7, 8. 8 digits it should move from right to left. When it is moving from right to left, we will get positive number. So 3.8446700. Okay, into 10 to the power of 1, 2, 3, 4, 5, 6, 7, 8. 10 to the power of 8. In this way you can write. Or not, just remove this. 3.84467 into 10 to the power of 8. Simple. This zeros also will come in the same way. Either if you write the zeros here or you don't write the zeros, it will give the same answer only. So after the point, this zeros has no value. So we go for the next fifth one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So there is a 18 zeros here. 0.1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 6. So the change of an electron, will be like this: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Yes. So this will be like this. So this we need to change in the standard form. So this has to move till it is a 18 zeros plus 1, 19. So 1.6 into 10 to the power of minus 19, because left to right. Simple. So in this way you can complete the sixth one again. The thickness of a piece of paper is 0.0016 centimeter. So simple, this decimal you move till here. 1.6 into 10 to the power of how many? 1, 2, 3 digits. So 10 to the power of 3 centimeters. So here minus 3 because left to right. Okay. Then seventh one. The diameter of a wire on a computer chip. The diameter of a wire of a computer chip is okay. This digit still move here. 5 plus 1, 6. 5 into 10 to the power of minus 6 centimeter. Next, fourth solution. In a pack there are 5 books, each 20 centimeters, 20 millimeters, and 5 paper sheets, each thickness is 0.016 millimeters. What is the total thickness of a pack? So there is a one pack here completely. In that there are 5 books, 1 2 3 4 and 5. There are 5 books in a pack. So here in each book there are 5 papers. In each book there are 5 papers. See that here there are 5 books. Here 5 books of 20 millimeters in thickness, and each paper thickness is 0.016. So what will be the total thickness of a pack we need to find. So to find out the total thickness of a pack equal to the total thickness of a pack equal to, here there are 5 books into each book thickness. Here he said that there are 5 books of thickness 20 millimeters. Okay, there are 5 books into each book thickness. Each book thickness plus we need to add there are 5 papers and each paper thickness. Papers plus into 5 papers into each paper thickness. So 5 papers into each paper thickness. So each book thickness will get, and there are 5 books into their thickness. So here they have given it 5 into here 20 millimeters each book thickness plus 5 papers. One paper thickness is 0.016 millimeters. That equal to 5 into 20, that is 100 millimeters plus here 5 6 are 33 cal. 5 1s are 5 plus 3 8. 5 zeros are 0 and 5 zeros are 0 millimeters. So when you add this 100.0.080, so we will get here 0.80001. So 100.08 millimeters. So this will be the thickness. If you want to write this in the standard form, just this decimal point you move from right to left till here. This is a decimal point. See, it is in the non-standard form. It is 100. It should be less than or equal to 1. Okay, here 1.12. This decimal point is moving 2 digits here. 0.8 into 10 to the power of n. It is moving from right to left. We have to get positive number. So how many digits? 2 digits. So 1.0008 into 10 to the power of 2 millimeters. So this is the thickness of a pack. In that pack there are 5 books and each book contains 5 papers and each paper contains a thickness 0.016 millimeters. So this is what. And there is the last question, that is the question number 5 here. See, Rakesh solved some problems of exponents in the following way. So he solved some problems here. Okay, do you agree with the solution? If not, why? Justify your argument. So Rakesh solved some problems here. I will write the solvers. See, here he said that Rakesh x to the power of minus 3 into x to the power of minus 2 equal to x to the power of minus 6 essence. Rakesh solved this problem like this. Is it correct or wrong? If it is correct, just you agree with the Rakesh, or not. If it is wrong, just you do not agree with the Rakesh solution. So you know that when you know this correct or wrong, when you know the properties, And loss of exponents, if you know the how to solve it, you can tell that either it is right or wrong. Let me solve that first. We'll take a LHS, that is x to the power of minus 3 into x to the power of minus 2. So it is in the form of, then we can use the formula here, a to the power of m into a to the power of n, that is equal to a to the power of m plus n. So here x to the power of minus 3 and minus 2, that is equal to x to the power of minus 5. So LHS equal to, we got x to the power of minus 5. It is not equal to RHS. Here LHS is equal to x to the power of minus 5, but Rakesh got x to the power of minus 6. So here LHS is not equal to RHS. As you will not be agree with the Rakesh solution, because we have done here 3 to the 6 hidden. That is not, actually you should add the exponents when bases are same. You did not do that. You multiplied that. Even you did not multiply properly also. Minus into minus plus should come, but here you got minus. Again it is a wrong. So you will not agree with the Rakesh solution in these conditions. So first one you have written a wrong one. Let us see the second one what you done. X to the power of 3 by x to the power of 2, that is equal to x to the power of 4. Let us see here in the LHS. Let us solve the LHS one and see the RHS, we get the same or not. X to the power of 3 by x to the power of 2, n. Bases are same, but they are dividing. A to the power of m by a to the power of n, that is equal to a to the power of m minus n. Yes, so we go for that. X to the power of 3 minus 2, that is equal to x to the power of 1. Okay, it is LHS. What is RHS actually? RHS, the Rakesh got x to the power of 4. So wrong. LHS is not equal to RHS. Yes. So here x to the power of 3 by x to the power of 2 is not equal to x to the power of 4 actually. So what is answer actually? X to the power of 3 by x to the power of 2 equal to x to the power of 1. So we have to say that I will not be agree with the Rakesh solution, because the correct solution is x to the power of 3 by x to the power of 2 equal to x to the power of 1. Here also we should write that x to the power of minus 3 into x to the power of minus 2 is not equal to x to the power of minus 6. Therefore is right. The correct solution is x to the power of minus 3 into x to the power of minus 2 equal to x to the power of minus 5. Okay, here also you have to write the correct solution. Okay, then the third one, see that x to the power of 2 1 to the power of 3 equal to x to the power of 2 to the power of 3, that equal to x to the power of 86. So x to the power of 2 1 to the power of 3, that equal to x to the power of 2 to the power of 3, x to the power of 2 1 to the power of 3 and x to the power of 86. So let us see that. First we will take these 2 here, x to the power of 2 and 1 to the power of 3. When you solve this, here you should get, this one will solve it first. So here you should get x to the power of 2 into 3, that should be x to the power of 6. So these two are not equal. Okay, here what you done, this you written x to the power of 2 and 2 to the power of 3 is written. The 2 to the power of 3 is written as a 8, but that is wrong. So the correct one is that. So I will not agree with Rakesh solution. We have to write the condition here also the same thing. I will not be agree with the Rakesh solution, because the correct solution is this. So because the correct solution is x to the power of 2 1 to the power of 3 equal to x to the power of 6. It is not equal to x to the power of this and x to the power of 8. So it will be like this. Then there are two more problems in this only. Again Rakesh solved it. Everything is all wrong. When you know that a problem is all wrong, when you know the correct one. If you know the correct one, then you will know what is wrong. So you have to be able to identify where it is written a wrong. So here the fourth one, x to the power of minus 2 is equal to root x. No, see that LHS side will take it. LHS equal to x to the power of minus 2. x to the power of minus 2 in the sense of a to the power of minus n, that we can write 1 by a to the power of n actually. So this will get 1 by x to the power of 2 actually. So this is LHS. Yes. So this will not be equal to RHS. Yes, here LHS is not equal to RHS. That means see that LHS is not equal to the RHS answer. That means here x to the power of minus 2 is not equal to root x. Yes, I will not be agree with Rakesh solution, because the correct solution is x to the power of minus 2 equal to 1 by x to the power of 2. This is what you need to write the remaining problems in the same way, and we go for the fifth one, and this is the last one. 3 x to the power of minus 1 equal to 1 by 3x distance. Let's see that here the exponent is only for the x. So here LHS is equal to 3x to the power of minus 1. So here a to the power of minus n equal to 1 by a to the power of n. So here 3 into this x to the power of minus 1 in the sense 1 by x to the power of 1. Nothing but here 3 into 1, 3 by x. It should become like that. The LHS should be equal to 3 by x. Here LHS is not equal to RHS answer. You got 1 by 3x. This 3 also is written in the denominator part. So here LHS is not equal to RHS. So I will not be agree with that. Means here 3 x to the power of minus 1 is not equal to 1 by 3 to the power of x. I will not agree with Rakesh solution, because the correct solution is the correct answer, the correct solution is 3 to the power of 3 x to the power of minus 1 equal to 3 by x. This is what. So this is the correct one and this is the wrong one. We have to tell where he written wrong and what is correct one. So see that Rakesh has written all problems are wrong. There we can identify when you know what is correct one. So learn how to do the laws of exponents and where we have to use, how to use the formulas accordingly. Everything we have discussed in this chapter. I hope you understood this chapter clearly. If not, once again and make it clear, because this laws of exponents formulas will be useful everywhere in your future also. So I hope you can do this. So keep practicing, keep learning and keep gain a knowledge. Thank you all.